Yo, this is Coach Ray. Back at it, starting a new unit. This new unit is called Exponentials and Logs. This particular lesson is called Geometric Sequences. This is not the first time we've done sequences this year. In the very beginning of the year, we did sequences. Anybody remember what those were called? Arithmetic sequences, very good. What was special about arithmetic sequences was the pattern was always adding and subtracting to get each new number. Okay, and then if you see this first line here, geometric sequences are if the pattern is multiplication. Okay, and I put this note here, division is the same thing as just multiplying by a fraction. So if we were doing 15 times 1/3, if you multiply straight across, you end up with 15 over 3, which is the exact same thing as 15 divided by 3. So really there's no such thing as division, there's just multiplying by a fraction. All right, and that's going to be important. All right, the blue line there, the common ratio is the number being multiplied in the sequence. Okay, so whatever the pattern is, whatever we're multiplying by, that is called the common ratio. Who remembers what that was called in arithmetic sequences?
Common difference.
Great job, common difference. So arithmetic, we had common difference. Geometric, we've got common ratio. All right, way back in the day when we were doing arithmetic sequences, you had a formula for the explicit rule. Okay, there's also an explicit rule for geometric. It clearly looks different. I won't make you memorize this formula, but this is the formula for explicit rule of geometric sequences. And so all you need to know here, a sub 1 is the first term in the sequence. And any guesses what R stands for? Common ratio. So we got to figure out the common ratio, figure out the first term, and then we can pretty much write the explicit rule for any sequence. All right, let's go straight to example 1. All right, in this problem, we started easy. I got 4 whole examples here, which might be too much, but I started easy, and then we'll work our way up and make it harder. In example 1, I think the common ratio is pretty easy to see. We're just figuring out what it's multiplying by each time. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. So my common ratio is obviously 2. Also, the first term is super easy to find because you can see it. Right? So I'm ready to write my explicit rule. I've got a sub n equals my first term is 5. You're going to see explicit rules of geometric sequences written a bunch of different ways. I could use a dot. I could use parentheses. So I'll try to write it in a bunch of different ways. But for this one, I'll do 5 times 2. And then it's always raised to the n minus 1 power. That's it. I just needed the first term. I needed the common ratio. And there is my explicit rule. You'll see this n minus 1 in parentheses a lot of times. It's all the same stuff. All right, in order to find the 20th term, anybody got a guess?
You plug it in for n.
Perfect, plug 20 in for n. Okay, I would not do that by hand. Okay, we're going to take this 5 and times it by 2, times it by 2, times it by 2, 20 times. So at some point it's going to be a big number. When you double it, it gets huge. Double that, it gets ginormous. So exponentials get big fast. So I'm using Desmos. I think I've already got it plugged in from last period, but let's look. All right, so if you look at the first line, I just plugged in the 5 times 2, and then notice the formula says I plug in 20, so it'd be 20 minus 1. So in Desmos, I just plugged in a 19. So that first top line is my answer, big old answer. 262, 1440. 262, 1440. All right, so let's see. I think Alex likes you to put commas in if it's a big number. Just a heads up. One of my students told me about that, I guess. Okay, but if we wrote that pattern out to the 20th number, that's where we'd be at, over 2 million. Crazy. All right, example 2. You notice the numbers are getting smaller. So that means what is happening?
They're getting multiplied by a fraction.
Multiplied by a fraction, okay? Or divided means the same thing. Okay, so we really just got to figure out what we're dividing by here. Easiest is probably to come here to the smaller numbers. 216 divided by 3 gets you 72. Okay, so you can double check it in the other ones, but if I'm dividing by 3, it's very important that your common ratio is 1/3. Okay, so my formula is going to need to include 1/3. All right, so a sub n equals, first term is easy again, they showed it to me. 1944 times 1/3 raised to the n minus 1 power. Fifteenth term. Let's look at Desmos. You see here in the second line I did it, 1944 times 1/3, and I just did raised to the 14th power because that's 15 minus 1. When I first plugged it in, it gave me, this decimal, because it's a really tiny number. So same thing, if I'm dividing something a whole bunch of times, it's going to give me a tiny number. I'm not sure how Alex is going to want you to plug this in. If it were me, I would want a fraction, because a fraction is exact. This decimal is rounded. But there's this fraction button over on the left-hand side where you can go back and forth between fractions and decimals. Okay, but we'll see what Alex wants. Try both and see what they're okay with. All right, but I got 8 over 19,683. 8 over 19,683. So far, so good? All right, next one, a little bit harder. Example 3. I'm going from 3/16 to 3/8, and I've got to figure out what I multiplied by in order to do that, and then make sure it's the same every time. One thing that a lot of people guess is they guess 1/2.
It's not right.
So we could check that. 3/16 times 1/2. If I multiply straight across, I'd get 3 over 32, which is not going to be 3/8. Anybody see what I can do to change that? If I do 2 over 1, I get 6 over 16, which would reduce to 3/8. Yay. The other thing I could do is cross cancel. I got a 2 here, 16 here, so that would turn into a 1. That would turn into an 8, so that's 3/8. Okay, so what I did to get from 3/16 to 3/8 is multiply by 2. 2 over 1, 2, same thing. And you can double check with the other ones. I'm doing the same thing every time, but you can trust me that that is the case. Okay, so let's see. Explicit rule. A sub n equals, I can see the first term again, 3/16 times 2 raised to the n minus 1 power. Okay, figure out the 25th term, piece of cake. You can see I plugged that in here, 3/16 times 2 raised to the 24th power, is 25 minus 1. And I got a giant number again, 314, 57, 28. 314, 57, 28. Oh, yeah. Put some commas in there. Still good? So the hard part about that was just figuring out with fractions what it's multiplying by every time. All right, example 4 is the hardest one. All right, so I want to make sure I pause here and kind of make sure we're okay. The reason example 4 is hard is because there's 2 things I need to plug into the formula. I need the first term and I need the common ratio. And when you look at example 4, you can't see either. Okay? All right. In order to figure, I'm going to start with the common ratio. Once I figure out the common ratio, then I can work backwards and get a sub 1. All right, I've got 128, I've got 2 here, but I know there's some stuff happening in between. I'm just going to be honest and tell you that I think guess and check is probably the easiest and most efficient way of figuring out the common ratio in power. Am I multiplying or dividing moving to the right? Dividing. It's getting smaller, right? So I've got to figure out what I'm dividing by. So I could guess. If I did 128 divided by 2, okay, that would go down to 64, that would go down to 32, that would go down to 16, and that's not good because that needs to be a 2. I don't even think 128 is divisible by 3. It might be. So I'm going to guess 4. If I did 128 divided by 4, I'm going to get 32. If I do 32 divided by 4, I get 8. 8 divided by 4, I get 2. Yay! There's my pattern. If I'm dividing by 4, what's the common ratio?
X
1/4. Great job. Okay. All right. Here's another way you could do it. I almost don't even like showing this because I think it's more confusing, but I'm going to show you anyway. I look at this. To get from 128 to 2, I divided by 64. 128 divided by 64 got me down to 2. Okay. However, I did something. In fact, more specifically, I multiplied by something, multiplied by something, multiplied by something. So, and it's the same thing each time. I multiply by the same thing each time to give me basically 64 there. Okay, so what that means is I could do the cube root of 64 because there were 3 multiplications. If I did the cube root of 64, that would tell me 2. That means it's changing by 2 each time. Okay, if there were 4 jumps, I would do the 4th root of whatever number that is. Okay? I don't care how you get the common ratio, as long as you get it. I personally think guess and check might be the easiest, most efficient.
So there's no surefire like way of just finding it.
That's surefire right there. Figuring out how many jumps there are and doing that root of whatever that number is. So if there were 5 jumps in between 128 and 2, we do the 5th root of whatever that
We did
number
the
is.
cube root of
Yes,
64.
ma'am.
One of these questions gonna be on your
And that's
test.
like-
Yes. The question was, are one of these questions going to be on your test? Yes. And I think on your Alex assignment that you're about to start, I think I put 2 of them on there. But I will definitely have a question like this in your test.
That's really easy.
All right. So let's see. We figured out common ratio. All right. A sub n equals, I don't know the first term yet. I'm going to leave a gap because I don't know yet. But I'll put this in. We figured out that it's 1/4 raised to the n minus 1 power. All right. If moving to the right, I'm dividing by 4, and we're multiplying by 1/4.
You can just multiply it by
Going to the left, I'm doing the opposite. I'm multiplying by 4. So if I do 128 times 4, take that answer, times it by 4 again,
By your first term.
that's going to give me my first term. Someone double check this for me. I believe it's 2048. I think it's 2048. Yep, okay, that has been confirmed.
Yeah, it's like 28 years.
All right, so I want to know the 10th term. Let's go back to Desmos, where I think I already have it plugged in. Yep, 2048. Okay, this 4th box here times 1/4. And then I wanted the 10th term, so I do 10 minus 1, I got an exponent of 9. It originally gave me a decimal answer. You gave me this 0.007. Okay, over here I clicked to give me my fraction of 1/128. Okay, so my answer is 1/120. All right, that is basically everything. There's one more little thing I want to show you that you probably could have figured out on your own, but I'm going to put it up here anyway because I think I have time. Let's say I start with the number 3, and I want to have a common ratio that's negative. I want you to see what happens if you have a common ratio that's negative. Let's make it an easy number. Let's make it -2. If I have a common ratio of -2, what's my next number? -6. What's my next number? Positive 12. What's my next number?
-24.
Okay, notice what's happening. If your common ratio is negative, it's going to alternate positive, negative, positive, negative. Because when you multiply the positive by a negative, it's going to turn negative. But then when you multiply the negative by a negative, it's going to turn back to positive. So I think I put one question on your assignment that kind of looks like that. All right, that's it for this video. Hope it helped. See you next time. Many more videos to come. Deuces.
It's supposed to be getting used to it.